Hey there. Welcome to Geography is Real channel. Here, you'll find real content-related physical geography, along with precise and direct descriptions of the same. Our goal is to foster a deeper understanding and appreciation for the natural world by exploring the wonders of the Earth's physical features and processes. Through engaging and informative content, kindly join us on a journey of discovery as we uncover the marvels and mysteries of physical geography. Don't forget to hit that subscribe button and ring the notification bell so that you never miss out on our latest content. Welcome. In this presentation, the major focus is on classification of rocks. Basically, the major focus will be on igneous rocks, sedimentary rocks, and metamorphic rocks. Rocks can be classified based on the following three main ways. 1. By their origin and mode of formation. 2. By their physical and chemical characteristics. And 3. According to their age. The three classes of rocks, according to their origin and mode of formation include 1. Igneous rocks, also known as primary rocks. 2. Sedimentary rocks, also known as secondary rocks. 3. Metamorphic rocks, also known as tertiary rocks. Igneous rocks are formed when magma or lava cools or solidifies on or below the Earth's surface. They are called primary rocks because they were the first to be formed. Formation of igneous rocks. Land-forming processes lead to the formation of lines of weakness or cracks within crustal rocks. Buildup of pressure in the mantle forces magma to move from the mantle through cracks into crustal rocks or on the Earth's surface. The magma that fails to reach the Earth's surface cools slowly and solidifies to form igneous rocks with large crystals, for example, granite. Upon reaching the surface, lava cools rapidly and solidifies to form igneous rocks with small crystals. For example, basalt, when cooling and solidification is extremely rapid on the surface, igneous rocks without crystals are formed. For example, obsidian. Classification of igneous rocks. Igneous rocks are classified into two major categories, namely, intrusive igneous rocks and extrusive igneous rocks, or volcanic rocks. The following schema shows the location of extrusive igneous rocks on the Earth's surface and intrusive igneous rocks in the Earth's crust. Intrusive igneous rocks are formed when magma cools and solidifies below the Earth's surface. Such rocks are said to be deep-seated and can be exposed through denudation. Due to slow cooling of magma, they form large crystals. Characteristics of intrusive igneous rocks. 1. They have large crystals. 2. They are hard and resistant. 3. They are coarse-grained. 4. They are compact. 5. They occur in large masses. 6. Some are formed deep in the Earth's crust, that is, plutonic rocks, and some at shallow depths, that is, hypabyssal rocks. How intrusive igneous rocks are formed. Earth movements form cracks or fissures, or vents in the crustal rocks due to heat and pressure. Magma in the Earth's interior is forced through the cracks and vents into the crustal rocks. The magma is trapped or intruded inside the crustal rocks. Magma cools and solidifies slowly to form coarse-grained rocks with large crystals. Types of intrusive igneous rocks. There are two major types of intrusive igneous rocks, namely hypabyssal rocks and plutonic rocks. Hypabyssal rocks are intrusive igneous rocks formed near the surface of the Earth. They are formed when magma cools and solidifies at a medium rate. They have medium-sided crystals. They are found in dikes and sills. Examples are dolerite, porphyrite, porphyry, diabase, lamprophy, granophyre, etc. Plutonic rocks. Plutonic rocks are intrusive igneous rocks, formed deep below the surface of the Earth. They are formed when magma cools and solidifies at a slow rate. They have large-sided crystals. Examples are granite, diorite, peridotite, gabbro, and syenite. Igneous rocks can also be classified according to their chemical composition. Hence the following four categories: acidic rocks, basic rocks, intermediate rocks, and ultra-basic rocks. Acidic rocks are igneous rocks, which have high silica content of 65% and above. They are light in color. They are also light in weight. Examples include obsidian and granite. This is the obsidian rock. It is an example of acidic igneous rock. This is granite rock, an example of acidic igneous rock also. Basic rocks are igneous rocks, which have low silica content of between 45 to 55%. They are dark in color. Also, they are heavy in weight. Examples include basalt and gabbro. This is basalt rock, an example of basic igneous rock. This is gabbro rock, an example of basic igneous rock, also. Intermediate rocks are igneous rocks with moderate silica content of between 55 to 65%, that is, they are between acidic and basic igneous rocks. Examples include diorite and andesite. This is diorite rock, an example of intermediate igneous rock. This is andesite rock, an example of intermediate igneous rock also. Ultra-basic rocks are igneous rocks, which have very low silica content of below 45%. Examples include peridotite. This is peridotite rock, an example of ultra-basic igneous rock. Next, let's have a look at sedimentary rocks, which are also known as secondary rocks or derived rocks. Sedimentary rocks are known as secondary or derived rocks because they are got from pre-existing rocks such as igneous and metamorphic rocks. Characteristics of sedimentary rocks. They are formed from sediments of pre-existing rocks, consisting of different sediments. They are laid down in horizontal layers called strata. They are non-crystalline. They are flexible, that is, they bend easily. They have bedding planes, meaning they are foliated or have a cleavage. Some have plant and animal remains, that is, fossils. Some have joints formed during consolidation. It is good to note that the layers or strata in sedimentary rocks are caused by change of composition of materials and seasonal change. However, the sources of sedimentary rocks include particles of pre-existing igneous and metamorphic rocks, remains of living organisms, both plants and animals, and precipitate of minerals dissolved in water. Classification of sedimentary rocks. Depending on their mode of formation, there are three classes of sedimentary rocks, namely, mechanically or physically formed sedimentary rocks, organically formed sedimentary rocks, and chemically formed sedimentary rocks. Mechanically formed sedimentary rocks. They are also called clastic rocks. They are formed from particles or sediments of pre-existing rocks on the land. Mechanically formed sedimentary rocks are further classified into three categories, depending on the size of their constituent particles, as follows. The first category is argillaceous rocks, which comprise of very small particles like those of clay or silt. Examples of argillaceous rocks include clay stone, mudstone, siltstone, shale, and loess. The second category of mechanically formed sedimentary rocks is arenaceous rocks, which comprise of medium-sized particles, like those of sand. Examples of arenaceous rocks include sandstone and grit. The third category of mechanically formed sedimentary rocks is rudaceous rocks, which comprise of small-sized particles, like those of gravel. Examples of rudaceous rocks include breccia and conglomerate. Organically formed sedimentary rocks. They are formed from the remains of dead plants and animals. The remains accumulate on the sea or lake bed or get buried on land. The organic materials accumulate in layers. With time, they are compressed into rock by the weight of the overlying materials. However, organically formed sedimentary rocks are further classified into 4 categories, depending on composition of materials and mode of formation as follows: calcareous rocks, carbonaceous rocks, ferruginous rocks, and siliceous rocks. Calcareous rocks are formed from remains of marine organisms, whose shells and skeletons are rich in calcium. Examples of calcareous rocks include limestone, coral rocks, and chalk. The second category of organically formed sedimentary rocks include carbonaceous rocks, which are formed when remains of plants that were buried thousands of years ago are compacted into rocks due to heat and overlying pressure of the crustal rocks. Examples of carbonaceous rocks include coal, bitumen, and petroleum. Ferruginous rocks are formed as a result of precipitation of hydrated iron oxide from water in lakes and marshes. Examples of ferruginous rocks include ironstone. The last category of organically formed sedimentary rocks is the siliceous rocks, which are formed from remains of organisms, such as diatoms and radiolarians, whose skeletons are rich in silica. An example of siliceous rock is diatomite rock, which is normally found in areas which were once underwater but became dry later. Chemically formed sedimentary rocks. They are formed as a result of evaporation of water from salt solutions or precipitates, leaving behind layers of salt, which are compacted into rocks. Rocks formed through evaporation are called evaporites. However, there are 4 major categories of chemically formed sedimentary rocks, including carbonates, sulfates, chlorides, and silicates. Carbonates are formed due to evaporation of carbonate compounds. Examples of carbonates include travertine or tufa, trona or soda ash, and dolomite. Sulfates. They are formed due to evaporation of sulfate compounds. Example of sulfates includes gypsum. Chlorides are formed due to evaporation of chloride compounds. Example of chlorides include rock salt. Silicates are formed due to evaporation of silicate compounds. An example of silicate is flint. The following is a summary table of sedimentary rocks, the last major classification of rocks, according to their origin and mode of formation, is that of metamorphic rocks. Metamorphic rocks are rocks which have undergone changes or modification of their texture, structure, and composition, physically or chemically, due to being subjected to great heat and pressure. They are formed through metamorphism process. Pressure and heat lead to physical and chemical changes in the original rock. The pressure is caused by 1. The compressional forces, which cause earth movements, and which result in folding of the existing rock. 2. The weight of the overlying crustal rocks. Characteristics of metamorphic rocks. They are hard and resistant. They are compact. Some contain valuable minerals, for example, metamorphic oriole, have different rock structure and texture from the original rock. What is rock metamorphism? It is a process where rocks undergo physical and chemical changes. to form new rocks due to great heat or pressure, or a combination of both. There are three major types of rock metamorphism, namely dynamic or kinetic or regional metamorphism, thermal or contact metamorphism, and thermodynamic metamorphism. In dynamic metamorphism, rocks change their physical appearance and chemical composition due to pressure changes. Pressure is due to compressional forces, which cause earth movements, and also due to overlying layers. In thermal or contact metamorphism, rocks change their physical appearance and chemical composition due to contact with the hot molten volcanic magma as it pushes its way up to the surface. In this case, a lot of heat is involved, and new minerals are formed through recrystallization. In thermodynamic metamorphism, rocks change their physical appearance and chemical composition due to a combination of both high temperatures and pressure. High temperatures are due to friction caused by earth movements and heat radiated from nearby molten magma. High pressure is due to compressional forces. There are a variety of factors that influence rock metamorphism or factors that affect or control formation of metamorphic rocks, as follows. Composition of parent rock before metamorphism. Heat and pressure during metamorphism. Rock resistance or hardness. Rock structure and texture. Rock porosity. Solubility of rock minerals, and chemical action of rock minerals. Examples of metamorphic rocks include diamond, gneiss, graphite, hornblende, marble, quartzite, schist, slate, and kissy soapstone. Here is a summary table of metamorphic rocks, showing the original rock and the resultant metamorphic rock. Finally, let's have a look at the significance of rocks to economy of a country. First, some rock formations such as Kitmi Kai of Western Kenya act as tourist attractions, who bring foreign exchange, which is then used to develop other sectors of the economy like health and education. Second, some rocks are exploited to provide building and road construction materials, thus promoting construction industry. For example, granite, gabbro, and dolerite. Third, some rocks have led to development of industries through provision of raw materials. For instance, limestone is a raw material for cement manufacturing industries, like Bamburi Cement Factory in Mombasa and Athi River Cement Factory near Nairobi. Fourth, some rocks weather and produce fertile soils that encourage agriculture. For example, sedimentary rocks in the lowlands parts of Kenya have weathered to produce suitable soils for growing cotton and sugar cane. Finally, some rocks such as aquifers act as storage for underground water, which is exploited for domestic, industrial, or agricultural uses. This is the end of this tutorial on rocks. Thank you for your attention. Please remember to subscribe, like, and share.